Hello, in this video, I'm going to talk about a linked list implementation of stack in Python. So the functions we are going to implement is get size is empty and peek and push and pop. Okay, so we are going to build a data structure in the following form. So what we're going to get is a head node indicating the beginning of the stack. So this is a head. And then we also maintain a second attribute, which is called size, so that we can look at how large this stack will be. So it is a linked list, which means that if I have a new node, so I'm going to have a next pointer points to a value. And then this will be the next pointer points to the next one. So this is the value. Okay, so this is the head, so which means that insertion. So then there will be the bottom, right? So the last one will be here. So the insertion, which is push, and deletion, which is pop. And also we're going to look at the first item, so which is a peek, will all be operated in this end, so that the beginning, we know that for this stack we have this name. So if you declare a variable name as a stack data type, then we can use s.head. Okay, and then which will be the one that we are going to so we got the dot head. So this x is the variable. So we're gonna this s dot head will be going to the beginning of the stack. So that is the data structure. We are going to implement, and then we are going to use Python, and we are going to implement stack as a class. Okay, so which means that we're going to define data structure, and also we're going to define operations, which will be operated on this stack. All right. Now we first defined this data structure. So we're going to get this data structure. So we have a value, and then we have a next pointer, and then we are going to call this a node. Okay, I'm going to declare this node as a class. So in Python, so we're going to declare class node column, and then we are going to declare these two attributes. To do so, that means that we're going to initialize this node, so this type. So we're going to use the special form of function called init for initialization, double underscore followed by init, followed by double underscore to indicate that this is a constructor for this data structure. So that it includes two parts. One is value, the other one is next. So in here, we are going to have a self. So because it is the constructor for this class that indicates self, so we're going to indicate the self, and then that will be the value. to begin with. Okay, so to begin with, and then we're gonna, so when we declare this node, and then we are going to say self, because that reference is self. So self dot value, which will be whatever value that your input is. So maybe I should use a val, so that we will, so this val it will be different from the value, because I'm going to indicate that two attributes. One is a value, the other one is next. At the beginning, it has a whatever value that you get from the input. So this is the value. So that you don't confuse this value with that value. Okay, and then we're going to assign this, and then we're going to, because at the beginning for this node, so next pointer points to nothing, points to none. So that is, now I declare this node, and then now I'm going to declare a class. So class will be in this form. Okay, so so again, we are going to declare class, we call it stack, and then we are going to same thing using double score init, double score, and self. So which means now I'm going to have this structure to build. Okay, so I'm going to say this is a stack class. So this is a class. And then we are going to first declare a node. Okay, so this is going to be next. Okay, and then I'm going to declare a head. And that head is actually a node. So which means now I'm going to, inside this head, I have a node. Okay, so the value for the node is head. And then this goes to empty. At the beginning, nothing. And then I have a size, and then I'm going to use a size here, which at the beginning is 0. So that's what I'm going to get. So when I insert, when I push a new node, I'm going to first declare a node, put the values in, and then I'm going to access this head and then change this pointer value and to point to this node. So this is a node, right? So that's basically the push. All right, so to declare this thing, so we are going to say self.head, so that declare head. Head is a node, so which means now this head actually has two attributes, and then the value attribute, I'm going to just use head. Let me put a double quote here. Okay, so this is head. So this is actually the value head. And then at the beginning, the size is 0. So I'm going to set self.size to be 0. All right, so once we have this, then we can implement size. So get size is straightforward because we have this size. So remember, anytime I insert a new node, we need to increase the size by 1. So increase the size by 1. And anytime we remove or pop off a node, we got to decrease the size by 1. So now let's see how we do this one by one. So this is double score. STR represents a string representation and also double score. Okay, so this is sort of like how I'm going to print the contents in the stack. So let me go back to this after we finish up the functions we would like to write. So first of all, we want to get size. So size, we simply, so you get size, the input is the stack itself, so which means self. So we return its size, we simply return self.size. Okay, so for instance, after I have pushed two items in it, so what we're gonna get here, so this is head. So the variable is a head, and then it has a value, which is string head. It has a size, which is the value here. So whatever size here, and then it has the next node. Say, I said I have two nodes, so the size then is equal to 2. Okay, so I get size simply means that self.head, and then I reference this particular attribute, which is the size. So I'm going to return self.size. And then if I want to know whether this stack is empty, we just need to know whether this is size, head.size is 0. So what we want to go to here is that we return self.size is 0. So which means that this is a logic operation to if self.size is 0, it returns true, otherwise it returns false. Okay, so that is second function. And then the next function is peek. So we're going to see what the value is in the on the top of the stack. So which means that it will be, right? So this is head. We're going to, it's the next node. So whatever in here, so this is the value attribute. This is the next. So this is the next. So which means there's a head dot next points to here. So we're going to return its value. So that's what we are going to return. Okay, and then because we need to indicate that this is the stack itself, so we put self dot head dot next dot value. That is the one we return if the stack is not empty. So first we're going to check if self dot is empty. Okay, is true. So if it's empty, then we're going to print that peeking from an empty stack. So which there is nothing you can return. Otherwise, we're going to return this, right? So this is what this function does. So next we're going to push one in. So the push one in, which means I'm going to insert a new node in here. So first, let's say the new node will carry a value. For the sake of clarity, so let me just say this is a value var. Okay, so that you don't get confused with this value with the attribute name value. It is the actual input. So what we're going to get is we're going to get a new node, so which means that this new node is the next pointer will point to this, and then we're going to direct this here. Okay, so how do we do this? So first of all, we will get a node. So let's say we're going to get a node. So capital N is the cars, and then we're going to have the value in it. So let's get val. Now don't forget that we need self to indicate that this is the stack for itself. So I'm sorry, we don't need it because node is already have. Okay, so this is node, so we get a new node. There's no need for this. And then we are going to change now. This is a new node here. Okay, so we got val, and then change is the next pointer, points to whatever points by head.next. So this is head.next is the first node. Now remember, for this head, we need to indicate this is self. Okay, so now we do this step, and then next we're going to redirect self dot head dot next to node, to this node. We point to this node, and then we are going to increase self dot size. We are going to increase it by 1. Okay, so that is push. So likewise, to remove an item from the top, which we call pop. So I'm going to indicate pop, the top of the value. So what it's going to be, we don't need to specify any input, right? Because this is removing. So what we do here is pop. So it means this. So this is a head. That's 3 attribute. Once again, this is head. This is the pointer, because this by itself is a node, capital N. And this is the size. So let's say I already have this. So obviously we need to first check that it is not empty, right? If it's empty, there is nothing. There is nothing to pop. So this is going to be the one I'm going to remove. So basically, when you remove something, you may want to know what I have removed. But the important part here is that I'm going to redirect this pointer points to here. So we first check, right? So check if self is empty. So if it's not empty, then we're going to pop. Otherwise, we're going to say, okay, there's an exception here. Raise an exception. So the exception, I want to put a message saying that this stack is empty. Otherwise, we're going to remove. So I'm going to remove this node. I'm going to call that remove. So that is a node. So this is going to be self dot head dot next. So that is the node I'm going to remove. And then I'm going to now remove. So this is, I'm going to call this remove. And then I'm going to redirect this link to the next one. So this is self dot head dot next. So it's going to be redirected to self dot self dot head. So this is going to be the next points here. But it should be the next, right? So I'm going to next. Or you can actually replace it with self dot head. And I'm sorry, you can actually replace, not this. You can actually, because now I have a remove represent this node. So it's a link points to the next one. So you can actually use a self.head.next to be removed next. Okay, so this is the equivalent. Don't forget to decrease the size. So now I'm going to decrease the size. After that, I'm going to return the value. So this is the remove that value is the value I'm going to return. Okay, so that is pretty straightforward. And then we are going to look at the one that we didn't look at earlier. So which is double underscore followed by str representing string. So this is a function to print out the contents in your data structure. So this is sort of a specified by Python. If you can indicate, you can write your own function to implement this string function. So what I'm going to do here is that I'm going to print the entire string, but then between to print the entire stack. So from top to the next one and to the next one. So in between, so let's say I have this. Let's say I have 1, 2, 3. So this is empty. And then what I'm going to print here. So this is 2, right? 1, 2, 3, but I want to say 1 is on top of it. So I'm going to use a greater than sign to indicate that 1 is on top of 2 and 2 is on top of 3. Okay, so that's what I'm going to print. Okay. So I'm going to start from my head. So this is the head. Now remember, head has 3 things. So this is indicate the value of that node, and then this is the size. Okay, so I'm going to call this, because this is from my beginning, so I'm going to call this current, or CUR. So CUR will be self.head.next, and then I'm going to print its value. So I'm going to print the current value. So basically what I'm going to say here is that I'm going to print CUR value, and then I'm going to add a sign here, a greater than sign. Okay, and then I'm going to move current to the next. So current then now is moving to the next. So what I'm going to do is the current going to the next. And then because I want to do this recursive, so so what I'm going to do here is that I'm going to okay, so I'm going to use my string function, so which means I'm going to form a string, right? So string, this is a string representation. So at the beginning, this string is empty string. So I'm going to use out to indicate that this is, I'm going to bring out. So out, beginning, this is empty string. Okay, and then the first one will, and then I'm going to print its value. So this is, the string is a print out its value. You don't have to use a print because this is a string. Because I have this double underscore str double underscore, when it has this content means I'm going to print it. So, and then this value and the greater than sign will be assigned to this out, and then move the current. So while the current is true, which means that when while it's true, right? So this is still true, but then when you move down to the next, then this becomes false when you go to the empty value, which none just means false. So while it still has content, I'm going to print it. But then when I print the whole thing out, I don't want to print the last greater than sign because that ends, right? So I don't want to, so let's say I'm here and then you still, according to this function, I'm still going to print space greater than space, right? So there's a space here. So these three I don't want. So the entire string, to print out the entire string, which will be represented by this. So the last three I'm going to ignore. So then return this. Okay, so this is going to be a pretty print. All right, so this is a Python implementation of linkless. So this is a Python code of linkless implementation of stack data structure. So now let's run this, right? So I'm going to run this, and then we're going to run this. So this one, I'm writing a Java code to test it out. So I'm going to first push numbers from 1 to 10. So I'm going to push them in. So the range then is from 1 to 11. So for I in range from 1 to 11, I'm going to push I in it, and then I'm going to print peak, right? So I'm going to print it. So every time I insert it, I'm going to print it as well. Okay, so, and then after that, I'm going to print the stack in a nice, in a nice way, right? In a nicer way. So using str representation that we just talked about, double underscore, str double underscore. Okay, so that is the first part. So this, then you see here, this is the result. So 1 is the one I push. I also printed 2 is the one I push, right, until 10. And then after that, I am going to print the entire stack in this form. So 10 is the last one to be pushed. So 10 will be on the top of the previous number, which is 9, right? So this is the one that I'm going to do. This is the one that you are going to see. And then we also test out pop. Okay, so now let's say I'm going to remove the top 5 elements, so which means I'm going to remove 10, 9, 8, 7, and 6. And each time when I remove one, I'm going to print it. So 10 is printed, 9, 8, 7, and 6. And then for the remaining stack, I'm going to print in the pretty print function. So so now once again, stack is the data structure, and we can use, right? So this is app. Now this is standard form. So app now indicates the data structure, and then this is stack. Stack here is a variable, or you can make this quote for the whole thing. So in this case, that you don't have a column here. So these two functions. Okay, so these two means the same thing, to print the stack. All right, so in the next video, I'm going to talk about underscore usage for names. Thank you for watching.